Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So in this video tutorial, we are continuing, from this lesson where we had to calculate, the volume of this, two tanks, the rectangular fuel tank and the cylindrical fuel tank. So we're using these dimensions, to help us answer the questions that are given to us here, right? So please make sure, if you know that you struggle with calculating, how much paint you will need. Okay, we're going to be discussing that in this question. How can you work with the surface area or the total surface area of a 3D shape to help us determine how much paint we will need? Okay, or if we are told that we need to paint 2 layers of paint, what does that mean? Okay, what does that mean? How would we work with the surface area to help us determine how much paint we would actually need? So please make sure that you watch this entire video tutorial and please take down notes. All right. So let's get started. Question 3.1.3 says, calculate in meters squared the surface area of the cylindrical fuel tank due to receive 1 quart of paint if we are told that the spread rate of the paint is 4 meters squared per liter, and we're also told that the cylindrical fuel tank has 2 openings, with an area of 12.568 centimeters squared each. They're telling us that the following formula may be used. So they're giving us the formula that we can use to help us calculate the surface area of a cylinder, right? So let's just analyze the information that is given to us there before we have a look at our diagram, because we've looked at the diagram in the previous question, but now let's just have a look at what is happening there, right? So we're given there the spread rate of the paint. So they're giving us the rate of it's a statement that gives us a rate. So what does this rate mean? It basically means that 1 liter of paint will be able to paint 4 meters squared of area. So all the time when you're given like a statement, right, where you're given a rate like 12 rand per liter, that is a rate, 5 meters squared per liter, so that per something, this per this, that is a rate. You can always change that rate, into an equation, right? And all the time, once you have an equation, once you've changed the rate into an equation that you can use, I promise you, life literally becomes a breeze.
I kid you not, my sweet friend. Come on.
Once you know what you want, you just multiply by what you want, divide by what you have, done. I promise you. So all the time, if you're given a rate, something per, 2 rand per something, a rate, something over something, where it gives you a rate at which something is happening, right? Write it as an equation, because if they're telling you, right, if they're telling you that it's 4 meters squared per liter, this rate can be written as an equation. This basically means 1 liter will paint an area of 4 meters squared. So that's this and this exactly the same thing. Exactly the same thing, just written in different forms. All right, cool. So that's basically what is happening there. Also, we basically told that the cylindrical fuel tank has 2 openings. Remember those 2 bobos, right? Those 2 holes that we spoke about, that hole and that hole, right? So we are basically told that the area, of that hole, is actually 12.568 centimeters squared each. So the area, the space that is taken up by this hole is, just gonna write it there, 12.568, 12.568 centimeters squared. The space that is taken up by this hole, it's 12.568 centimeters squared. So that basically means that, right, if we had to now calculate the total surface area, remember when you're calculating total surface area of a 3D shape, we're just trying to determine, what are all the areas, right? What is the area of the top, the bottom, and that curved part? Okay, we're adding up all those areas together, okay, and that gives us total surface area. But now, if we've got holes, imbobo, right? That basically means that we need to remove that, okay, because obviously space is not being taken up by that hole. It's empty there, right? Okay, so obviously if it's empty, that basically means that you're not going to be painting that part that has a hole. You're not going to be painting that. So that means that you want to exclude that from the total surface area. Okay, so that's what our thinking has, where our thinking needs to go. That is why I always try to, when I'm explaining, these concepts of surface area, volume, I try to move away from just working with formulas, but I show you how, we get to these formulas, because if you know how these formulas come about, when you get problems like this where it's more of application and you've got holes and you don't have a lid at the top, then you are able to work with these formulas because you're now thinking at a deeper level, as opposed to just working with a formula. You don't know where the formula comes from, you're substituting, then it shows you flames. Okay, so in this case, right, we can see first thing that we need to do, definitely going to calculate the total surface area of this cylinder. Then the next thing that we want to do, right, we want to subtract those areas of those holes. Why? Because it's empty there. If it's empty, if it's a hole, that means that, obviously we're painting around the hole. We're not painting where there's that hole. So obviously that means that that is going to subtract from our surface area. Okay, and we are done. Right, so that's where we need to be when it comes to our thinking, right? So it says that now we need to calculate the surface area of the cylindrical fuel tank that is due to receive 1 coat of paint. So if you had to paint the cylindrical tank once, we're going around it once, what would be the surface area that you would paint? Okay, so from here, remember, okay, at this point, yes, use the formula, okay, just to make sure that you've remembered your formula correctly, okay. When you're calculating surface area or total surface area, let's write it as total surface area, okay, total surface area of the cylindrical tank, okay, to be painted, okay, with 1 coat of paint, right, is equal to, right? So I'm just going to draw the cylindrical tank here so I don't have to go back and forth. Okay, we're given that the diameter is equal to 56 centimeters. Okay, we're given that the height is equal to 82 centimeters. And we're given those 2 holes there, okay? And we know that the area of each hole, okay, is equal to 12.568 centimeters squared. Okay, very important. So now let's go to our formula, right? Remember, we want to calculate the area of the top and the bottom, right? So remember, okay, with the use of a net diagram, right, when you're calculating the surface area of a cylinder, right, obviously if you want to open up the cylinder, this is how it would look, right? So obviously you want to calculate what is the area of the top and the bottom part. Those are circles, hence why you've got that 2 times pi times radius squared. So it's pi r squared. That is the area of how you calculate the area of a circle. But you've got 2 circles. Hence, you've got that 2, right? Plus, okay, how do we calculate the area of this rectangular part? Okay, so how do you calculate the area of the rectangular part, right? So if you've watched this video tutorial, I've given you guys an in-depth explanation of how you derive that formula. Okay, so it's that 2 pi r. So that 2 pi r is actually that length there. Okay, it's the circumference of your circle. Okay, it's the circumference of the cylinder. It's 2 pi r. It's length. Okay, please watch this video if you don't know what I'm talking about. Please, right? Okay, multiplied by okay, that height there. So this is 2 pi r multiplied by height. Okay, that is how we calculate the circumference of your cylinder. Okay, so working with your application of what we already know. Okay, so very easy. I'm just gonna obviously just use my pi. I'm gonna say my pi is approximately equal to 3.142. I'm gonna use that, as my pi. Okay, so it's gonna be 2 multiplied by, what is my pi? 3.142 multiplied by, what is the radius? Okay, so the radius, remember, it's just going to be the diameter divided by 2. Okay, so the radius, I'm just going to do here, radius, okay, is equal to your diameter, 56 centimeters divided by 2, okay, which is 28 centimeters. Okay, so it's going to be 28 centimeters all squared plus 2 times 3.142 times radius, which is 28 centimeters, times what is your height? It's 32 centimeters. Okay, remember here, right? Okay, you're asked to obviously calculate the surface area to receive 1 coat of paint. Okay, and they asked us to calculate it in meters squared. Okay, so please note here, guys, you can just obviously convert all your values to meters, or you can keep the values in centimeters and convert the final answer to meters. Or I hope I won't be confusing anyone here, right? It just depends on you, what you're comfortable with. If you're not comfortable with converting that final value to a value in meters, what did I say, cubed, to converting that final value to a value in meters squared, just convert. Okay, just start off, ladies and gentlemen. Okay, if you're not comfortable, just start off by converting that 32 centimeters to meters. Okay, just divide by 100, and then work with those values in meters so that your final answer is just in meters squared, right? But also, you can also look at it this way. I promise you, it's not really a train smash. Okay, you can work with them as centimeters, right? And then we convert that fine. I'm going to show you how we can do that, okay? Because the reason why I'm not converting my units to meters as yet is because I want to just, work with that, those holes, right, that are given to us in centimeters squared. Okay, right, cool. So let's just quickly do that. So if you punch this into your calculator, if you take 2 multiplied by 3.142 multiplied by 28 all squared, you'll find that, okay, this is equal to, I'm not going to round off, ladies and gentlemen, okay? But please take notes in your exam. You need to just follow the instructions that you are being given. Instructions, you read the instructions page, because that's where you get a guide on how you need to go about rounding off, okay? So that you need to read that, or you need to read the questions, right? Maybe the questions are also going to tell you how you need to go about your rounding off, okay? So please, there, let's just be clear. It depends on the instructions. I'm not rounding off because I want to maintain accuracy. Okay, so let's just take note of that. Okay, I've got 4,926, 656, right? This is centimeters squared plus, then I'm finding the value here. Okay, if you say 2 times 3.142 times 28 times 32, that basically gives us 5630.464 centimeters squared. Centimeters times centimeters, centimeters squared. Then you take that 4,926.656 plus 5630.464. Then you're gonna find that, okay, the total surface area of the cylinder is 10,000, okay, 557.12 centimeters squared. So we've just now calculated, just look at what I'm drawing here, okay, the total surface area of the top, the bottom, and all the sides, okay, assuming that the cylinder has if the cylinder had no hole, okay. But now remember, we want to find out what is the surface area to receive 1 coat of paint. right? So we already know that obviously you've got holes there. We've got holes. Those holes, we're not going to be painting those bubbles, right? So that's why we need to now subtract the area of those holes from this area, okay, to then be able to obtain what is the total surface area that we're actually going to be painting. All right, so then all that we need to do here, the final step here, is that we're going to therefore take, to get the volume, to get the total so to get the total surface area, okay, to be painted, we are just going to take that amount of 10,557.12 centimeters squared minus, we want to minus that first holes area, okay, which is 12.568 centimeters squared. We're going to also minus that other holes area, minus 12.568 centimeters squared. Okay, so same as just saying minus 2 times 12.568 centimeters squared. Okay, so let's just quickly do that. So we're going to minus 12.568 minus 12.568. Therefore, the total surface area that is, okay, that has to receive 1 quart of paint is 10,531.984 centimeters squared. So that's the total area, okay, surface area that we're actually going to be painting, okay. But remember, they wanted us to determine what is the total surface area that has to be painted in meters squared. We've got our answer in centimeters squared. So what do we need to do? Promise you, these diagrams are revolutionary, okay. So all that we need to do, we're just going to take, okay, we're just going to take these diagrams and we're going to modify them to suit what we want now. It's meters, centimeters, millimeters. Remember, we want to convert these centimeters squared to meters squared. So what do we need to do? Multiply by 1,000, multiplied by 100, multiplied by 10. This is what we already know, né? When we want to convert between the different units of length. This is what we know. This is easy. Okay, right? This is easy to us. We can do this in our sleep. But now, what we need to remember, we're not converting units for length in this situation. Okay, we are converting units for area. So we're not converting centimeters, but we're converting centimeters squared, right? So if you want to convert between different units of measurement for area, just need that. Remember that you can just change this. Okay, you can just change this diagram to be kilometers squared, meters squared, centimeters squared, millimeters squared, right? And what you did there, that means that also this 1,000, it's not going to be 1,000 anymore, but it's going to be 1,000 squared. 1,000 squared, ladies and gentlemen, is 1,000 times 1,000. Okay, we are multiplying 1,000 twice, so it's 1,000 times 1,000. Okay, 100 squared, 10 squared. Also at the bottom, square it, square it, square it. So now how will we convert that 10,531.984 centimeters squared to meters squared? Easy now, okay? We are moving from centimeters squared. We want to go to meters squared. We are not going to divide by 100, ladies and gentlemen, but we are going to divide by 100 squared. Right? So therefore, okay, the surface area is equal to, you want to take that 10,531.984 centimeters squared. You want to convert it to meters squared. You want to divide by 100 squared. Okay, so you're going to take that 10531.984 divided by 100 squared. Is it penny? 1.0531.984 meters squared. So that's the total surface area that we want to paint. Right, that's the total surface area that we want to paint. Right, so that's it. Okay, that is what the question is practically asking for. Okay, calculate the surface area of the cylindrical fuel tank that is due to receive only 1 quart. So if we're just going around this tank, right, with just 1 quart of paint, okay, with just 1 quart of paint, we would just be painting an area of 1.0531.984 meters squared. Cool, right? Let's look at B. So determine the total area of the total surface area to be painted with 2 layers of paint. So now, if we're not going or painting this tank once, we are painting it once, which was the area of 1.05, and we're going around that, or we're painting that tank again, that actually means that we'd actually be painting a total surface area of, let me just label this, 3.1.3, this is 3, okay, this is 3.9.3a, right? Then this is b. Okay, so then if we had to paint this cylindrical tank with 2 layers of paint, okay, then the total surface area, okay, to be painted would be this 1.0531984 meters squared multiplied by 2. Okay, if you multiply that by 2, we'll actually get that it's going to be 2.10636968 meters squared. So that's then the total area that we would paint if you painted once, okay, and you painted again, okay, 2.10636968 meters squared. So give the amount of paint to the nearest liter needed to paint the outside of the cylindrical fuel tank. So remember now, in this question, right, we're still remembering that, okay, we're painting the cylindrical fuel tank with 2 layers of paint. How much paint would be needed? How much paint, right? So we're going to go back to the statement that is given to us here that's telling us about, that the spread rate of this paint, okay, we're given a particular paint, and this paint, if you've got 1 liter of this paint, that 1 liter of that paint is capable of just painting for an area of 4 meters squared. If you've got 1 liter of paint, that 1 liter can paint an area of 4 meters squared. Write it down. Let's write down that equation. So we had C. We want to determine how much paint will we need. That's what we're trying to determine. Okay, how much paint will we need? If this paint, we're told that 1 liter can paint an area of 4 meters squared. So obviously this is the total area that we want to paint that one. This is the total surface area that we're actually painting, because you're going and you're painting the cylindrical fuel tank twice. Okay, so literally remember, ladies and gentlemen, once you have an equation that you can work with, I promise you it's a breeze. Okay, so all that you need to do, you take that 2.10636968 meters squared. That is the total surface area that we want to paint. Okay, that is what we want to paint. That is the area that we want to paint. So now all that we're trying to do, we are trying to determine how many liters of paint will we need. How many liters of paint will we need? Let's start there. So remember, if the question is asking us to what is it that we want, ask yourself, what do we want in this case? Okay, in this case we want to determine how many liters of paint do we need. Multiply by what you want. You want the liters in this case. Multiply what you want. Multiply by 1 liter. We want how many liters of paint will we need. So we're going to multiply by 1. Obviously, we need to use both these values in this equation, right? So if you've already multiplied by 1 liter, that just means that all that's left for you to do is just divide by that 4 meters squared. Divide by what you have, okay? Then meter squared, they cancel. What do you get? Okay, you get, this is the same as just taking 2.10636968 times it by 1/4, or even just saying divided by 4 gives us 0.5265992 liters of paint. Okay, so that basically means we need half a liter of paint to paint, this cylindrical tank with 2 layers of paint. But remember now, okay, the question took it a step further. It asked us to give the answer to the nearest liter. Okay, so we can't obviously leave it as half a liter. Okay, so what do they mean if they're saying the nearest liter? Okay, it just means that what is the total amount of paint that you need? We want a whole number. Okay, we don't want about 0.4 liters of paint. We want a whole number. Do you need 1 liter of paint? Do you need 2 liters of paint? Okay, that is what the question is asking you, right? So in this case, what's going to help us, with the rounding off to the nearest liter? We're going to look at this value, okay? That value that is after the comma, that value is going to help us round off to the nearest unit. Okay, nearest liter, right? So in this case, that 5 just tells us that this 5 tells us that that 0 just needs to go up by 1 unit. Okay, so then the total amount of liters that you'll need to paint, this cylindrical tank with 2 layers of paint is just 1 liter. You need just 1 liter when you round it off to the nearest liter. Okay, I hope that makes sense. D, give one reason why the fuel tank must be painted. So with this question, right, you just need to think, why do you think they'd want to paint a cylindrical fuel tank? Okay, the first thing that I thought of, if we're painting steel or something that is of metal, we're painting it probably because we don't want it to rust. Okay, so to prevent it from rusting. Okay, so to prevent the tank from rusting. All right, and that is it, ladies and gentlemen, for today's video tutorial. Okay, I remember I once got a question where one learner or student asked me to look at questions where they want us to determine how many liters of paint will we need. Okay, all the time when you're given those questions, right, you're given a statement that gives you the spread rate of the paint. Okay, it tells you 4 meters squared per liter. It gives you how much area can 1 liter cover. So in that case, you just need to remember that you just need to change that rate into an equation that you can use to help you answer whatever question that they can throw at you when it comes to determine how many liters of paint will you need. Okay, right. So that's the first thing. Being able to change that rate into an equation. 1 liter will be able to paint an area of 4 meters squared. Then from there, the trick with this question is just realizing that our cylindrical fuel tank had holes. It has holes. So meaning that if we've got holes there, we're not going to be painting those holes. We're painting around the holes. Meaning that when we're calculating the total surface area of the cylindrical tank, yes, we will calculate it the normal way that we calculate the surface area of a cylinder. But we just need to remember that we need to remove those holes because they're not included. We're not painting them. Hence why they gave us the area that is covered by the holes, if you get what I'm saying. Okay, so we had to remove those holes there. Okay, and then from there, smooth sailing. Also, the conversions, ladies and gentlemen, converting is very important. You need to now develop these tricks, okay, that I'm giving you, these tips and tricks. When you want to convert units of measurement for area, use the same diagram, but just modify it to suit what area? Kilometers squared. Okay, times it by 1,000 squared, 100 squared, 10 squared. Change that, and then it becomes easy. You can convert these centimeters squared to meters squared easily. You don't have to worry with, oh my gosh, all of them need to be in meters first. Even if you have your final answer in centimeters squared, you can still work with that. Doesn't make you panic. All right, and then we are literally done. I hope you enjoyed this tutorial, ladies and gentlemen. I did say, okay, I'm helping you guys prepare for your finals. We are uploading every single day, 6 p.m. I'm not going to skip. No, come rain or snow, please make sure that every single day you're glued to that screen and you watch these video tutorials, because I promise you they will definitely help. Okay, I'll see you guys on my next tutorial. I'm going to be looking at cooking conversions. Okay, actually, sorry. Before we get to cooking conversions, let's just do this. Okay, in the next video tutorial, we're going to be looking at this question, right, where we obviously have to determine, the radius of 10. We have to determine a question where they, trying to trick us. Okay, when it comes to, if you're working with volume and they're giving us that, this tin is being filled up to that, right? What is the height? Type of a situation where obviously we are, the question is a bit tricky. It's not coming in a form that you guys are used to, where it's just substitution. What do we do? So please make sure that you watch the next video tutorial, because we want to be looking at also, those type of questions, right? Determining the radius of paint tin, the highest level reached by the paint in the tin, right? And in liters, the amount of empty space in the tin. So if you obviously given that this tin paint or paint of tin is being filled to a particular height, what is the volume of that empty tin? Do you see that now we're working with application questions? Okay, we're working with application questions. So I hope you guys are gonna really be enjoying these tutorials, and I'll see you guys on my next upload.
That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.